Hello, my name is Mark Ellis from Stick and Rudder Studios, and today I want to continue with our video series concerning some new capabilities that we put in for Stream Deck support, remote virtual devices, and basically dynamically drawing images. And today I want to talk about two new features that we've added to X-KeyPad 1.7.0 Beta 15. And that is the ability now for Stream Deck devices to be able to support dynamically modifying a SVG file, a scriptable vector graphic file. And this is basically an extension of what we presented in the last video where we were dynamically modifying SVGs on the remote virtual devices. You now can do that on the Stream Deck with Beta 15. The other thing we're going to cover today too is an extension to what you can modify in the SVG. We now have the ability to modify the actual text attributes or text elements within SVGs. So if you've got one with text in it and you want to dynamically modify that text, you could do that now too, and we'll demonstrate that to you also. So first out of the chute, I do want to share with you, if you are using a Stream Deck, one of the things we had to do in order to support this new capability is we had to modify and enhance the API communication API between the X-KeyPad plugin that runs on X-Plane and the X-KeyPad Stream Deck plugin that runs over in the Stream Deck software. So the first thing you're going to notice once you've installed X-KeyPad in Beta 15 in X-Plane is the first time you bring X-Plane up, you're going to get this message indicating that the API versions don't match. And you could see here it's showing you that the API is version 4 in the Stream Deck plugin, but the KeyPad API version is version 5. So that indicates that the Stream Deck plugin is behind one revision. And we can actually see that if we come over here. If you give me 1 minute to bring up the Stream Deck software. If I come over here and I right-click on this, you'll see that this Stream Deck software is at 1.7.0 Beta 6. Now that we're on Beta 15, we've got to upgrade this, to the newer version. So it's pretty simple on how you do that. First what I'm going to do is come over here and dismiss that. And we'll come back over here. We just right-click and tell it to uninstall it. And then we come over here to where X-Plane is, and I'm using X-Plane 11, but the structure is the same. We're going to go to Resources, Plugins, X-KeyPad. We're going to go to the SD plugin, and all we have to do is double-click on this SD plugin. And we're going to say go ahead and install it. And you know it's installed properly if you come down here and you right-click on it, and it says 1.7.0.15. That's the version we need. For X-KeyPad 1.7 Beta 15 to talk to the Stream Deck, so those API versions are compatible with one another. All right, so we'll shut that down. We'll get this out of the way here. Okay, so the first thing we're going to do is we used the embedded Lua sample that I had for the Boeing 737. I enhanced it to take care of this extra SVG image we're going to display on the Stream Deck, and I'll show you that in just a minute. But the first thing we're going to want to do is import the Lua script that goes along with this sample. So we're going to come up here, X-KeyPad to the Lua script configuration editor, and we're going to do a file append. And it's going to be under Resources, Plugins, X-KeyPad, Samples, Embedded Lua, and it's going to be under the Boeing 737, and we're going to import this. And if you recall from a number of videos before, we already had one script in here, which was the dynamic radio digit generator, where we were using a 7-segment font, for the Stream Deck encoders to do the radio, so they kind of looked a little more realistic. What I've had it here now is the 737 flaps indicator script, and this is the thing that's going to drive that particular flaps indicator over on the Stream Deck. And while we're at it, why don't we take a look at what that image looks like. you can see that I've added the 737 flaps SVG to the script file, and this is what it looks like. It's basically just like you would see on the flaps gauge on a regular Boeing 737. And what we're going to be able to do with this is, it's not just going to, I mean, you could have done this if all you wanted to do is have it show 1, 2, 5, 10, or 40. You could have done that with simply 9 different images and then dynamically selected the image based upon where the flaps were. This one, we're going to actually animate it. This needle here is going to move very smoothly as the flaps are moving, and it will stop at the detent where the flaps are displayed. And you'll actually be able to see this showing up on the on the key. Okay, so we've got the Lewis script installed. Now let's come over here to the Stream Deck configuration and just make sure we don't have anything in the definition list. Let's come over here and append that sample. So it's the same thing. It's going to be under Resources, Plugins, X-KeyPad, Samples, Embedded Lua, 737, and here is the Stream Deck configuration file. Okay? And what you'll see here, if we go to the definition list and we go to keys, you'll see that I've added a flaps, key here. And why don't we go ahead and go to that, go to the background image, and you can see here that I have selected that particular image. Okay? So why don't we just bring up the Stream Deck stuff here and we could take a look at it. Let's see what might be the best way to look at that. So you can see here, probably not that easy to see, but I think if I come over here, I think I've got this on the virtual device. Yes. And if I make this virtual Stream Deck thing show up, see it shows up, it's a little bit bigger. You can see it better. Okay. So now what we're going to do is I'm going to show you how this script can actually animate this guy. Okay. Let me move this over here. I think that will stay on top. We can just leave that like that. We're going to go ahead and save that. And let's look at the script and walk through how it works. Okay. So there's a fair number of comments up here, but the basic concept is that we're going to have a function here. The main function is called draw flaps. And what we're going to do is register this function down here with the do before, so that what happens is before every flight loop, X-KeyPad is going to call this draw flaps function. And this number here says to call it every 50 milliseconds, around 50 milliseconds. I mean, obviously, if your frame rate is slower than this, it might be that you actually end up calling it more than 50 milliseconds apart. If your frame rate's pretty fast, you'll probably call it pretty much every 50 milliseconds. But basically, this is a fast enough refresh rate that you'll get a pretty smooth animation of this flaps indicator as we come up and do it. So this draw flaps function is going to get called every 50 milliseconds, and we'll walk through it here in a minute. We have a couple of supporting functions up here that we're going to use. First, we've got this round function here. We've used this before. We've defined this with a couple of other scripts. And the concept is that when we do the calculations, this thing could calculate out to a rotation angle on this needle here down to a thousandth of a degree or a hundredth of a degree. There's no point in trying to re-render this image on a hundredth of a degree change. You would not even be able to see it, okay? So we're going to use this round function to basically round out any rotation angle movement so that it's down to, I think I might have done it down to a tenth of a degree. We'll take a look at it. But, 1 degree or 1/10 of a degree changes, that you actually could probably see those in the animation. And by rounding it down to something a little more coarse, at least what you're not doing is spending a lot of CPU cycles re-rendering the image and sending it over to the Stream Deck far more than you really need to, okay? Then we also have another function here called getAngle, and this is going to do something very similar to what we did with the airspeed indicator in the remote virtual device SVG example. The angle of the rotation angle of this needle here is not linear through all of the steps, okay? As you matter of fact, you can see that if you look at 90 degrees, it's actually right in between the 2 and the 3. So we're going to need to do some interpolation in here. And effectively what you've got is you've got 9 different flap positions. And up at the very top of the script here, you can see that I have a couple of arrays that give us information. So for flaps percentage, we know that for each of the 9 positions of the flaps, what you're going to get is a flaps percent that goes from 0 to 12.5%, which is 0.125. Then it goes to 0.25, 0.375. Basically, as you drop the flaps, it moves itself all the way up to 100% deployed, and it goes in 0.125 increments, 0 to 1.0, for indicating 100% flaps deployment. Now, what we now want to do is have a corresponding array that's got 9 entries that tell us how much angle rotation do we need to apply to this needle based upon where the flaps are at any given point in time. So at the flaps 1 position, which is 0.125%, that's 35 degrees of rotation. That means we have to rotate this needle 35 degrees to the right to get it to point to the 1. If it's 0.25 or a 25% flaps deployment, we need to rotate that thing 76 degrees, which would point it to the 2. Okay? So you get the concept. So what these 2 arrays are going to be used in conjunction with this getAngle function here, the getAngle function, we're going to call this getAngle function anytime we need to calculate how much rotation do we need to apply on that needle. And we're going to pass in a number between 0 and 1.0, indicating 0% flaps deployment all the way up to 100% flaps deployment. And then I'm not going to get into excruciating detail as to how this function works. You can go through and kind of do the math on it. But basically the concept is it iterates through the 9 positions, looking at these each 9 entries up here in these arrays. Basically the flap percent, the needle angle. It says if the flaps are between 0 and 0.125, then we know that we're going to need to rotate this angle somewhere between 0 and 35 degrees. And whether it's 100% of the 35 degrees or something less, it's all based upon, interpolation. Where is the flaps percent between 0 and 0.125? It's like, if it's like 0.1, well, that would be a certain percentage into that 35 degree rotation range. So all it's trying to do is calculate, how much rotation do I need to apply onto this needle based upon where the flaps are currently at. Okay? And then it simply returns what that angle is. It has a couple of guard bands in here. You should never see this, but just in case the flaps percent is less than 0, I don't know why you would ever see that because it's coming right out of X-Plane. Or if the rotation angle were ever to be calculated greater than 270 degrees, which is all the way around here, we basically want to limit it so the needle doesn't rotate either below the up or to further than the 40 degree flaps range, okay, that you see on this dial. Okay, and then in the draw flaps function, this is what's going to get called every 50 milliseconds. We're going to come in here. First thing we're going to do is we're going to open the SVG image by its unique ID. And again, the way I can get that unique ID, if I come over here to image data, if it's an SVG file, there's going to be a little button here that says copy the SVG. And that's the unique ID of that SVG file. So that opens up the SVG. The next thing I'm going to do is limit the SVG image size to 96 pixels. This is basically the size of the Stream Deck XL key. If you do a little Google search, you can find out it's 96 pixels. It's 96 by 96 pixels square. Now, why do we limit this? I mean, if we take a look at this SVG, I can't remember exactly what size it by default is. Let me actually see if we can bring it up here and look at it in the editor. So if we go to X-KeyPad, samples, images, I threw this in here so that we could actually look at it. And let's edit this with Notepad++. So you can see here that the view box that they've set up for this is 200 by 200. So if you don't limit it, what's going to happen is when X-KeyPad decides it needs to re-render or create a new image, a new rasterized image of that SVG, it's going to end up using, this data here, and it's going to end up producing a raster of 200 pixels by 200 pixels. Now in the end, that still could get displayed perfectly fine on the Stream Deck. But the problem is it doesn't need to be that big. What's going to happen is we're going to push it over there as a bigger image, and then the Stream Deck's just going to turn around and try to scrunch it down, okay, with with its normal size reducing algorithms. So there's two things that happen with it. One, you're sending more data over than you really need to, so it'll have some nominal impact on performance. I could tell you if we had this be something like 1,000 by 1,000, it would definitely impact the performance because you'd have to send that big stinking image that you redraw for every 1/10 of a degree or whatever you've got it set up to do it at, send that over, and then it's just going to get scrunched down to a 96 by 96 pixel thing. So the whole idea is don't do that if you don't have to. Make it the size that it needs to be, and you'll find that things perform a lot better. So that's what I did here. If you don't do this, it's gonna get rendered or created in whatever the size is of the SVG based upon how it is defined. The next thing we need to do is then come around and figure out what does that transformation attribute need to look like. And like we had with the other things, if we come back over here, let's search for that. The element ID here, let me move this out of the way. The element ID we need here is needle. That's what we defined it in the SVG file. Search for needle. And here it is. And here is the transform attribute. So if you remember correctly, these numbers here, like the 100.10107, 99.97, these are basically calculated by Inkscape to figure out where does it think its real center of the rotation is. And it's never, you would think that this would be perfectly in the center of, if it's a 200 by 200 image, you would think it'd be perfectly in the center of 100 by 100, but inevitably there's slight variations. And if you get these off a little bit, the rotation doesn't look right at all. So these are kind of constant values here we're going to want to keep in. And then here's the actual angle we're going to rotate by. It's, in the SVG, it's set to 0, which is basically, pointing to the left here like this. And we want to rotate it around to the right. So we need to basically replace the 0 with the angle we want to move it to. And that gets done basically with this, let me make this a little bit bigger so you can see it. That's what's done with this string dot format. Effectively what we're doing is putting in the words rotate, and that's basically what that transform attribute needs. %2f is going to get me my angle, and then here are the two constants, the 100.10107 and 99.973114, right? And then the value we're going to pass in is we're going to do a round on the flap rotation, the flap ratio that we're going to get out of Stream Deck, and that's defined up here. Flap ratio is this data ref sim cockpit controls flap panel deploy ratio. And we're going to round it to 1 decimal point, okay? So this local string is going to get set to that, that new transform attribute value, and then we're going to use set SVG image attribute. Needle is the name of the attribute. Needle is the name of the element ID. Transform is the name of the attribute that we need to change. And this is the new rotation value that we want to put in there. And then all we need to do is then close the SVG image. And when you close the SVG image, what X-KeyPad does is it said, did you make any changes to it? If you did make any changes to it, it's not going to bother to regenerate the raster image, and it won't send anything new over to the Stream Deck. The Stream Deck will have exactly what it had before. If you did change something like, it did need to rotate a little bit to the right or rotate a little bit to the left, it will regenerate the image and send it over to the Stream Deck. And I've designed this to be pretty high performance. The generation of that image is actually going to get done in a separate thread. So it should not have really any significant impact on your flight loop. I mean, obviously, if it was a really big image, it may take it a while to generate it, and it's going to take it a while for it to send it over to the Stream Deck. So what could actually end up happening there is you don't see quite as rapid of an animation as you expect, and you could actually end up having it where it lags a little bit from where the flaps are really positioned. But at this size, the images that are being sent over, they're not that big, and they actually get generated and sent very, very quickly. So you should see that it's going to look pretty close to what's really going on. Okay, so that's how this works. It's very similar to what we used in the previous videos on modifying things like the airspeed indicators and the directional gyros that we did in the remote virtual devices. Exactly the same concept, except in this case, we're going to render this over on the, the Stream Deck. So let's actually test it. One thing to know is probably worthwhile to come in and see how I made this key work. Okay, Stream Deck configuration. Let's go to the flaps. If you go to the commands, you'll see that I use a short press and long press type approach to this thing. So on the short press, you're going to get a flaps down command, and on the long press, you're going to get a flaps up command. So if I just come over here and I'm going to click on this, you can see that it's animating. The flaps are going down. And just to prove to you that I'm not faking this in any way, shape, or form, that's interesting. I'm not quite sure why I don't have this plane fired up here, but well, that's interesting. Even with the plane not launched, the flaps move. Yeah, there you go. See, and you can see they're pretty much following each other. And a long press will bring it back down. Okay, so where do you want to use these? This is a rather very good example of where you'd want to use this, where you want to have an image on the Stream Deck that has a lot of different positions that you need to be able to show. And if you were to try to break this up, I don't know, let's assume that this in order to make this look nice like we just did, this could end up getting broken up into maybe like 150, 200 images. That's just completely unruly to try to do that with a logic test, with that many logic tests. It's just crazy. And this is where there's a very good use. If you really want to animate something very finely, or you've got a lot of different positions you're trying to show, this is where this can come in pretty handy to do this. If all you really have is you have an image that's maybe like a 3-position switch, where you're trying to show it in position 1, 2, or 3, I don't think I would bother doing this. Okay, with with an SVG. I mean, you could. There's nothing wrong with doing it. It's just that it's a little bit more compute intensive to regenerate this image and send it over there, even though it's, in the grand scheme of things, it's relatively negligible. But if you actually had 3 separate images, they get cached over in the Stream Deck, and the change between image 0, image 1, and image 2 is like lightning fast, microseconds effectively, where this actually takes a little bit of time to do. So use this SVG approach when you need to do it, okay? When you want to have more animation, or you want things like multicolored text on the key, which you can't really do right now with the Stream Deck, or you want part of the text to be static, but other parts of the text you want to change. That's where potentially using a SVG file can come in handy if you really want to do that level of work. Okay, so that's it on the Stream Deck. Nothing really all that odd about it. It's very similar, okay, to what we did on the remote virtual device samples. Okay, so what I'd like to do now is I want to switch over to showing you how you can modify text on an SVG, which is a new capability. So if you give me a minute here, we'll come right back after I have the Cessna 172 loaded up. Okay, so here we are in the Cessna 172, and what I've done is modified the remote virtual device directional gyro so that the SVG remote directional gyro, so that it could actually have the current heading of the aircraft displayed as text in the center of the SVG. So let's do the same thing. Let's come in here. let's bring in the Lua script that drives this. We're going to do an append. And this time we want resources, plugins, X-KeyPad, samples, remote virtual devices, because that's where we're demonstrating this. Cessna 172. And let's add that. Okay. And you're going to see in a minute here that what we modified was this SVG sample. We'll look at it in just a minute here. So let's just save that. And let's come over here and bring over the remote virtual device example. Same thing, resources, plugins, X-KeyPad, samples, remote virtual devices, Cessna 172, and this guy right here. Save these things. Okay, and let me now fire up my remote virtual device. Let's come over to X-KeyPad, remote virtual device, Windows, and we'll fire this guy up. And if we come over here to SVG gauges, you're going to see that what I've done is I have a text image that I put in the middle of here that shows you what's your current magnetic heading, okay, that the plane is on. And what we need to be able to do now with this is we need to be able to modify this as the magnetic heading of the aircraft changes. Let's come over and take a look at how we do this. So first thing to do is it's probably worthwhile to take a look at that SVG file because I did have to change it. We'll go here to samples, images, and it is the heading indicator. I'm going to edit that with Notepad. And really quickly, I need to remind myself what in God's name I called that element. That does the vertical speed. Here's the draw SVG. Yeah, here it is. I called it heading text. So search for heading text. And there it is. And you can see what I have here is a plain vanilla, HTML or SVG text attribute. And here's the ID. And again, what you have to have is you have to have an ID on it in order for X-KeyPad to be able to locate it. And here we have a font, and I am going to discuss this a little bit. I actually decided to use a custom font. This would be a font that you don't normally find, on your system. It's the 7-segment font that we actually have available as normal text rendering within X-KeyPad. I'll show you how we have to put that font in a particular location, but I am specifying a special font that's going to give you a 7-segment look and feel to it. And then here we've got some styles and stuff like that that Inkscape decided to put in, but in the end, move this over here a little bit so we can see it. You can see here, this is where the text tag ends. And by default, it has the text in the SVG of 360 degrees. Now, obviously, we got to modify that, right? Your plane's not always going to be pointed north, magnetic north, right? So as the plane moves, we got to change this text in here. And let me show you how that's going to happen. So move this out of the way. If you remember correctly from the previous YouTube tutorial, we talked about how you do this dynamically modifying the SVG when it's on a remote virtual device. You notice that we've got this draw SVG heading indicator function that gets called every time the remote virtual device wants to render that key. And we did a bunch of things in here, right? We had a calculate in here, what should the dial get rotated to, for the heading, and how should the little heading bug get rotated based upon where you've got the heading bug, pointed to. But now we've got a new one here too. We also now have to modify the heading text. And we do that by first coming up with what do we want that text to be. So same thing here, we have a string.format. We want this to be always three characters, and we want it to have leading zeros. So in other words, if the heading is 10, we're going to always have it display as 010, right? And three places. 0.0f means no decimal places, so we're not going to try to get things down into down to a tenth of a degree. And here we're going to round the DG heading variable, which is effectively the data ref for what X-Plane thinks the magnetic heading of the aircraft is, and we're going to round it with no decimal places to the right. So effectively it's going to get rounded to the nearest whole degree, which is good enough for what we're trying to do in displaying here. And then all we have to do is call the set RVD draw element SVG attribute. And here's where things get a little bit interesting, where we added some stuff. The element ID is heading text, as we said. That's the ID on the text element within the SVG file. But then the attribute name, we're using this constant called text data. There is no attribute ever called text data in an SVG file. There are things like transform, other things of that nature like fill color. Text data is not something you would normally find. I had to have some way of identifying the data in a text element because it doesn't have the attributes of a text element are things like its fill color, its weight, its font, a whole bunch of other things, but there's no way to reference the actual text that's in the text element. So this is one way I could tell X-KeyPad, oh, by the way, this guy is a text tag, and I don't want you to change a attribute. I want you to actually change the text. So that's what this constant text data means. And then here, heading value is whatever we calculated we want to be displayed in there. So when this gets run, it's going to go ahead and shove that right in there. And I think, if I'm not mistaken, if I do an adjustment on the, let me just close these down here real quick. Bring up that SVG. Yeah, I think if I adjust the, see, I'm not actually trying to move the aircraft around. I'm just basically adjusting the alignment of the directional gyro, which will change not only does it change the dial, but you can see that the text is changing too, right? And then what I'll do is I'll just, I think I did a non-click on here where it zeroes out that. But if I come over here and I go to, yeah, that guy here, on this one I made it so that when you push it, it basically does an alignment of the directional gyro to magnetic north. And if I bring the remote virtual device back up and we go to, yeah, you can see we got this back to where it should be. That's the real heading of the aircraft 252. So you can see how that works, and this is kind of nice, and this is useful. There's going to be times where you're going to want to modify the text on a SVG item, and this is like a really easy way to do it, and it's pretty high performing. Okay, so it should do the trick for you. Now, you can't see it very well, but this is actually a 7-segment font that we're using here. And to the best of my knowledge, a 7-segment font's not a typical font that you would find on an operating system. So what I did is if you come over here to X-KeyPad, there's a font folder here, and I just happen to have the 7-segment and 14-segment fonts that come with X-KeyPad. We actually use these when you're doing labels on the the remote virtual device, you can use these. What I did is I want to use them in the SVG. And in order to do that, you have to be able to copy them and put them in a folder where the XVG rendering software that I'm using can actually find it. And the reason why I didn't always look for it over here is the remote virtual device can actually run on a separate machine. So I wanted you to be able to put the fonts wherever that remote virtual device was running, okay? So if you actually come in here and you look under X-KeyPad and we go to remote virtual device, Windows, and it would be under anything, there's another folder here that we've added called SVG fonts. If you want to use something other than what comes with the system, you need to put that font in here. And that's all I did. Otherwise, what will happen is, if you refer to a font that's not on the system that can't be found, it'll default back to, I think it's Arial is what the default font that it's going to go to. It'll still look okay, but because its size is slightly different, it might not be exactly positioned where it's supposed to, and it won't look like a 7-segment font. In most cases, you probably don't need to use a special font for most of your stuff. An Arial font's going to be perfectly fine. But if you do want to use a custom font or something unusual, just remember that you've got to put it over here in the SVG fonts directory here, as well as the one over here. You've got to put them there, because this is where it's going to look if you have to render it for a Stream Deck, because it gets kind of rendered and built right with an X-KeyPad by itself, whereas with the remote virtual device, all of the rendering is happening over in that remote virtual device application. It's one of the reasons why it's as fast as it is and has such a limited impact on frame rate. So those are the new features that we've got. Again, they're very advanced features. Most people probably aren't going to be using it, but if you want to get fancy and you feel like you've got some programming skills you want to show off, you can do quite a bit with this. I think at this point we have remote virtual devices in pretty good shape. I think the Stream Deck stuff is in pretty good shape. In the next beta, my primary focus is going to be getting this all documented, because at the moment the documentation doesn't show you how to do all this fancy stuff. Get that updated, get that done, and then what we're going to do is move on to rewriting the editing UI for the X-Touch Mini, which is the next major thing we need to do in 1.7. So as you guys use this stuff, please provide feedback on the X-Plane.org forums or over on Discord. Let me know what you think, and if there's anything else we need to do to make this more usable for you. Okay, great. Thank you very much for your time.